Hello everyone, welcome to Vision Tech Solutions channel. In this video, I'm gonna show you how we can do EIGRP summarization with the leak map. Actually, the leak map is used to enforce longest match routing traffic engineering. Sometimes when we want to do the traffic engineering, we use the leak map to achieve our goal. So let me go to the scenario which we are going to do the lab. So in this design, we have routers R4 and R5 in AS100, EIGRP AS100, and we have R1, R3, R6, and R7 in the actually EIGRP named mode, and the named mode is multi-AF, and they are in AS200. So we are going to configure EIGRP on these two routers. Then what we are going to do, we have two loopbacks on R4, loopback 40 and loopback 41. And we have two paths to go to the R4 to reach the loopbacks. One from the DMVPN tunnel and one from the directly connected link, which is between R4 and R5. So our goal is to do the traffic engineering somehow that when we want to reach the L40, loopback 40 on R4, we use the DMVPN tunnel, and if this link goes down, we use the directly connected. So by looking at the topology, we might guess that for R5 to go to the loopback of L40, it will use a directly connected route. And we can test it. We can just verify that after we establish the EIGRP adjacency, and we will check how R5 will route the packets to go to loopback 40 after we actually redistribute them into the EIGRP, and then we have to achieve this goal: the primary route from DMVPN and the backup route from the directly connected. And then for R1, again, we have two loopbacks, loopback 60 and 61, and we want to do the traffic engineering. So R1 will take this route, this path from R3 and R7 to R6 to go to the loopback of, instead of going this way, instead of going directly to R6, it uses this path. So let's go to the requirements and the tasks that we need to do. So this is EIGRP summarization with link map. Configure EIGRP in classic mode on R4 and R5 using AS100, and it should enable EIGRP over both DMVPN cloud and Ethernet segment. So let's do this from R4 and R5. So I go to R4. So first of all, let's take a look at show IP interf brief. So this is the directly connected gigabit 1.45 is a directly connected route, and here we have DMVPN tunnel. So DMVPN tunnel, the IP address is 155.1.0.4, and so we have to enable EIGRP on them. So basically what I will do, I enable the EIGRP on both the Ethernet link and the DMVPN tunnel. So conf-t router EIGRP 100. So I add the network 155.1.0.0 00255.255, so which is tunnel interface, and I add the network 155.1.45.0 with the subnet with the wildcard mask of 000-255, which is this interface. So I've enabled on this interface and the tunnel. I will do the same for R5. So show IP interface brief. As you can see on R5, this interface, which is gig 1.45, which is this interface, and the tunnel. So actually the same network, router EIGRP 100, network 155.1.0.0.0.255.255, and network 155.1.45.0.0.0.255. So show IP EIGRP neighbors. So you can see that I have adjacency over the DMVPN tunnel and this interface. Okay. Now let's go to the tasks. Multi-AF on R1, R3, and R6, and we have to enable the EIGRP on 155.1.00/16 AS200. So let's do this on all 1, 3, and 6, which is we are going to configure in named mode. So in named mode, so R1, R3, R6, and R7. So on R1, router EIGRP. Now I use the named mode. The name is multi-AF. So when we are in name mode, address family, IPv4, unicast, autonomous system 200. Then we go to network 155, because we want to enable on all the interfaces 155.1, which are the Ethernet interfaces of R1. So if I show IP int brief, so the interface with 155.1 is 146, and the tunnel interface, also this tunnel interface. But actually there are two separate EIGRP, so we will not form adjacency with R5 only because it is in AS200, it is in AS100 for R4 and 5, but we just enable on 155.1.0.0. Okay, so the way we do that, after 1.0.0 and the 00255. Okay, so this is R1, R3, the same. Router EIGRP multi-AF, address family, IPv4, unicast, autonomous system 200, and network 155.1.0.0.0.255.255. This is 0, then 6, T, router EIGRP multi-AF, address family, IPv4, unicast, autonomous system 200, and network 155.1.0.0.0.255.255. Okay, and R7, router EIGRP multi-AF, address family, IPv4, unicast, autonomous system 200 and network 155.1.0.0.0.255.255 and show IP EIGRP neighbors. So R7, we have neighbor with R6 and R3, but not with R1. So let's see, show IP EIGRP neighbors with 6 R1 with we have neighbor with 6 and 3. So show run section EI. Let's see. This one is okay. Multi-AF. Show run section EI. This is multi-AF. Multi-AF. This one is okay. R6. Show run section EI. This one is also okay, and R7. Bad IP address as host name. Find the computer address. Let's see. Why we are not forming adjacency with, because okay, that's okay. So R7 with because we should be neighbor with R6 and R3. R6 should be neighbor with show IP EIGRP neighbor 6 with 1 and 7. 3 should be 1 and 7. 1 and 7, and 1 should be 1 with 3 and 6. Okay, that's okay. So our neighbor adjacencies are up, as you can see. And now we'll go to the next requirement. Configure the following interfaces on R4 and redistribute them into EIGRP. So we create 2 loopbacks on R4, and then we need to redistribute them into the EIGRP. Now let's go see how we can do that. So int L40 IP address 4.00. The IP address is 4004 255.255.255.0, and int L41 IP address 4014 255.255.255.0. We show IP int ref. So we have 2 interfaces. Now we want to, when we want to redistribute them into the OSPF, so we use the IP prefix list. IP prefix list. We call it connected to EIGRP. We give it a sequence 5 permit 4000/24, and we give it a sequence 10 and 1. Now we have to specify the route map that matches these two, let's say we name it connected to EIGRP, the name of our route map. And match IP address prefix list, the prefix list that we just created. So we created a route map for that allows these two subnets. Now when we want to redistribute them into EIGRP, just we have to go to router EIGRP 100, and then we go redistribute connected links, and then we give it the route map that we just, so the connected links that match these two prefixes or these two interfaces. So now if I go to our show IP route EIGRP, and as you can see we have now two external links, because when they are redistributed they are showing as external. We can see them on R5. The same we will do on R6 with loopback 60 and 61 on R6. So we go on R6, int L60 with the IP address 6006.255.255.255.0, and int L61 IP address 6016.255.255.255.0. Now again we have to do the same thing. We have to create the IP prefix list. IP prefix list I connected to EIGRP. Let's sequence 5 permit 6000/24 and sequence 10 6010. Now we create a route map, call it connected to EIGRP, that match IP address prefix list connected to EIGRP. Then now for this one, because we used the named mode router EIGRP multi AF address family IPv4 unicast autonomous system 200, we have to go to the topology base, and here we can do the redistribution. Redistribute connected and route map that we specify. Okay, cool. Now if we go, for example, to the neighbor, let's go to R1, which is the neighbor of R6, show IP route EIGRP, and you can see that we have these two interfaces. The same as we go to R3, show IP route EIGRP, so we can see these two. Now let's move with the requirements. It says configure R4 summarization on R4 to advertise a default route into EIGRP instead of redistributed loopbacks. So the reason why we want to advertise a summarization advertising a default route, because we want to do the traffic engineering. So with the leak map means the longest match, because this router, when we want to route the packet, if if this R4 is advertising a default route on this link, and then it advertises the route with the longest match, R5 will choose the route with the longest match. It will not choose the default route. So I will show you how we can do that. So first, we have to advertise a default route into EIGRP instead of the redistributed loopbacks. So what we want to do, instead of these two, we just advertise a default route. It means in order to reach these two, just go to the default. So in order to do that, I go to the R4. I go to the interfaces, and both interfaces like int gig 1.45, and then I issue the command IP summary address EIGRP 100, and I use the default route. And yeah, I have to put the subnet mask. So this is the default route. I go to tunnel 0, also IP summary address EIGRP 100 0000000. So I use the summary route on both interfaces. I mean the tunnel and the Ethernet. So I will do the same for the R6. Let's exit route. I go to the interface. Actually, for this one, because it's a named mode, I have to go to the EIGRP multi AF address family IPv4 autonomous system 200. Then I go to AF interface. So for R6 we have two interfaces, 67 and 146. So gigabit 1.67 first, go summary address 0000000, which is the then link map. I'm not going to do the link map now, then I will show you how we do the link map. So this is this interface. I have to go to the other interface 1.146 interface gig 1.146 and summary address 0000000. Now we are advertising the summary address. So if I go to show IP route EIGRP, and you can see that I only have one default route. And if I go to, let's say, router 1, show IP route EIGRP, so here you can see that I have the default route. Okay, now the requirement is, it says configure a link map on R4 so that traffic going to R4's loopback 40 prefix is routed out the DMVPN cloud, and if this long link goes down, it should be routed the Ethernet link between these devices. So now if I go to R5 and if I ping 4004 and trace 4004, and you can see that I am routing through the connected link. 45.4 means it's going through the connected link, but I want the traffic going from the DMVPN tunnel, because 45.4 is a directly connected link. That is how I'm now reaching R4. So in order to do that, I have to again create one prefix list, and based on that match the loopback interface with a route map, and then when I am advertising the default route, advertise that route to R5. So R5 will choose the longer match to reach R4, which is the DMVPN tunnel. Now I will show you how we can do that. So IP prefix list, I call it loopback 40, and permit 4000/24, then route map, I call it leak loopback 40 match IP address prefix list. So the prefix list that I created is loopback 40. Okay, now I want to advertise loopback 40 out the DMVPN tunnel. So when R5 wants to route the packet to loopback 40 of R4, it looks at the longer match, and the longer match is from the DMVPN tunnel. So instead of sending it from the directly connected link, it sends it through the DMVPN tunnel. So in order to do that, right now, if I go show run int tunnel 0, so you can see that right now, sorry, I had to create it. I think I created on the wrong router, not R. Okay, on R4. I had to create it on R4, not R5. So no IP prefix list. I just delete it from here, and no route map. Leak 40. Okay, on R4. I had to create it on R4. IP prefix list, loopback 40, permit 4000/24 route map leak loopback 40 match IP address prefix list, the loopback 40, which is our prefix list. Okay, now if I go show run int tunnel 0, so tunnel 0 now it is summarizing a default route. So int tunnel 0, I say no And now what I will do, I have to add the leak map. And for the leak map, I'll put my route map here. Okay, cool. And I leave the other interface the same. So on R4, so if I go show run int gig 1.45, 45 is advertising a default route, but DMVPN tunnel is advertising a more specific route now, 4.000. Now if I go and I'll trace route 4004, and there you go. You can see that now I'm going through the DMVPN tunnel. I'm not going through the directly connected link. So previously I was going through the connected link. Now after I applied, now I'm going through. Now if the tunnel goes down, for example, into tunnel 0, shut down, and trace route 4004, and you can see that I'm going through the connected link. So it means that when R5 wants to route the packet, it goes through, it checks the longer match, which is 4004 is longer match than the default route. So IP route EIGRP, although we have a default route advertised, but, and of course, yes, that is how it is working now. So I will do the same on R6. So let's see how R6. So the next requirement on R6, traffic from R1 going to R6 is routed through the Ethernet link between R1 and R3. So it means from R1 to R6 it should go through this. Now let's go and check after we applied the ping 6006 and trace route 6006. So it goes through the directly connected link, right? Because it's directly connected from R1, sorry. Trace route 61006. So it is going through 146, which is the directly connected. Now what I will do, again, I will create a longer match on R6, IP prefix list, loop back 60, and permit 6000/24, then route map leak loopback 60 and match IP address prefix list, the prefix list that I created, back 60, and now I have to apply it on this interface 67 because I want R1 to choose this path. So when it is seeing the longer match from this path, it will send the traffic to R3 instead of sending it to directly connected link. And how I should do that? So right now, if I show run section EI, so you can see that on both 67 and 46 we have the default. So on 67 we have to add our leak map. So conft or just let's do this Okay, now I go to AF interface 67. I remove this and I add this one, but with the leak map. And for the leak map, I use my actually the route map that I created, leak 60. That's it. Now, if I go to R1 and trace route 6.006, and there you go. You can see that previously I was routing through directly connected link. Now I'm going to R3, which is 13.3, then going to R7, which is 37. That's 7, and then going to, so I'm using the different paths. So in this lab I showed you how we can use the leak map for a longer match traffic engineering. So if we want, so we advertise a default route and then we advertise a longer match through one of the links, so the router will choose the longer match instead of the default route. I hope this lab has been useful. Thank you very much and see you in the next lab.